Now let's look at empirical probability. Empirical probability applies to situations in which we observe how frequently an event occurs. So the probability of an event is, or equals, the observed number of times the event occurs divided by the total number of observed occurrences. So we can still think of it as what we want over the total amount. The only difference between empirical and theoretical probabilities is that in theoretical, we're thinking about what should happen, and in empirical probability, we've actually done an experiment, or we've collected data, and we're finding the probability based on that, the what actually happened. So let's look at this example. The table below shows the educational attainment of the U.S. population ages 25 and over. Use the data in the table expressed in millions to answer the following questions. So if we look at our table, they tell us the population. If we look at the different educations, it's less than 4 years of high school all the way up through 4 years of college or more, and they have it broken down into male and female. Notice the last row and the last column, both are the totals. So this bottom right-hand corner where we have 174 tells us that there's 174 million total people that were collected in this data set. So we're going to find the probability expressed as a simplified fraction that a randomly selected American age 25 or over. And let's also look at the decimal answer, because you may see that in your homework as well. And so in part A, we want that they had less than 4 years of high school. So remember, it's what we want over the total amount. So I know that denominator is going to be 174 because that's the total number of people we've collected data on. If we're looking at all of the people that had less than 4 years of high school, notice they're not breaking it down into males or females. So I'm going to look at this less than 4 years of high school, and I'm going to go down to the total amount. So that gives me 29 over 174. So I'm going to do 29 divided by 174, and that gives us this decimal. So let's say that we're going to round decimals to the nearest hundredth. That's 2 digits after the decimal point. So if I do this, that 0.1666 repeating, right, that 6 tells me to bump it up. So I'd say in decimal form, it's about 0.17 for our probability. Now if we want this in simplified fraction form, what I'm going to do is just hit the fraction button in my Desmos calculator, and that tells me that the simplified fraction form is 1/6. So depending on how they asked me to answer the question, if they wanted the probability as a decimal, I'd write 0.17. If they wanted it as a simplified fraction, I'd write it as 1/6. Let's look at part B. They said had 4 years of high school only. So I know that total amount is still 174. If I'm looking at the 4 years of high school only, once again, they didn't tell me males or females, so I'm going to go down to that total, and it gives me 56. So I'll do 56 divided by 174. That gives me this answer as a decimal. I want to round to the nearest hundredth, so that I have that 0.321. The 1 tells me to leave the 2 alone. So I'd say that probability in decimal form is about 0.32. If I want it as a simplified fraction, I'll hit that fraction button, and it gives me 28 over 87. Let's look at part C. In part C, they say was a woman with 4 years of college or more. So my denominator is still 174, the total number of people we're looking at, but this time I want a woman with 4 years of college or more. So I'm going to go over to 4 years of college or more, and I'm going to look at this female row. Remember, female goes along with women, and male goes along with men. So 22 is going to be my numerator. So I'll do 22 divided by 174, which gives me, when I round my decimal, right, I have 0.126. The 6 tells me to bump that 2 up. So I would have 0.13 in decimal form. and I'll hit the fraction button to get a simplified fraction. Gives me 11 over 87. If we look at part D, they say was not a man with 4 years of high school only. So remember that not is our complement. So if we're looking for the probability that it was not a man with 4 years of high school only, I'm going to do 1 minus the probability that it was a man with 4 years of high school only. So that's going to give me 1 minus. I know I'll have 174 as my denominator. If I go up here and look at a man with 4 years of high school only, that's this 25 right here. So if I do 1 minus 25 over 174, in decimal form, when I round to the nearest hundredth, right now I have 0.856, the 6 tells me to round up, I'd have about 0.86 for my answer in decimal form. I'll click the fraction button. It gives me 149 over 174. One thing I want to point out is that a common mistake I see happen is people will instead just tell me 31 over 174, because they'll just look at the females then that are in the 4 years of high school only. Notice what they said though. We want was not a man with 4 years of high school only. So we want everyone except those 25 people that were right here, the male with 4 years of high school only. So we want to include everyone that had less than 4 years of high school. We want to include the females with 4 years of high school only. We want to include everyone with some college and everyone with 4 years of college or more. So let's look at part E. Was not a woman with 4 years of college or more. So if we're thinking about that, we have a not again, and we have not a woman with 4 years of college or more. So that probability that it's not a woman with 4 years of college or more is going to be 1 minus the probability that it is a woman with 4 years of college or more. So if I look up here, woman with 4 years of college or more, was that 22? Right? So I know as a probability that's 22 over the total, the 174. So when I do 1 minus 22 over 174, when I round that decimal, it gives me approximately 0.87, because I had 0.873. The 3 told me to leave the 7 alone. And when I hit the fraction button, it gives me 76 over 87 for my answer as a simplified fraction. Let's look at another example where they give us a graph. So the graph shows the distribution by branch and gender of the 1.42 million, or 1,420,000 active duty personnel in the U.S. military in 2011. Numbers are given in thousands and rounded to the nearest 10,000. So here we actually do have to pay attention to the units. Notice they tell us that the numbers are given in thousands. So when they gave us the total amount, they gave it to us in millions and in thousands. Because all of the other numbers are in thousands, we want to use that 1,420,000 that has the same units, the thousands of people. So they give us this bar graph where we have the active duty U.S. military. They give us the men with those purple bars, the women with the pink bars, and they have it broken out by branch of service and the number of active duty in thousands. So they ask if a person is randomly selected from the population represented in the bar graph at the bottom of this page, so it's really not at the bottom of the previous page, but above. Find the probability expressed as a simplified fraction that the person is, part A, not in the Navy. So remember that probability that they're not in the Navy is 1 minus the probability that they are in the Navy. So I'll do 1 minus. If I'm looking at the probability that they're in the Navy, I need to include the 270 males and the 50 females. So that's going to give me 320. So that's what I want over the total amount. I'm going to use what they gave me up here, that 1,420. If I do that, they're telling me just to answer as a simplified fraction. So I'll do 1 minus 320 over 1420. I'm going to hit that fraction button, and it gives me 55 over 71 as my answer as a simplified fraction. If we look at part B, they're asking is not a woman in the Marines. So the probability that it's not a woman in the Marines is 1 minus the probability that it is a woman in the Marines. So I'll do 1 minus. If I look for the probability that a woman's in the Marines, they tell me that there's 10,000 women in the Marines out of that total amount that we're thinking of, that 1,420,000. So if I do that, 1 minus the 10 over 1420, and then I want my answer in simplified fraction form, gives me 141 over 142. One thing I want to point out, notice we're not just looking at the 190 men that are in the Marines. We also want to include everyone that's in the Air Force, everyone that's in the Army, and everyone that's in the Navy in our answer if you're choosing to just add everything up rather than use the subtraction. If we look at part C, we want is not a man in the Army. So the probability that it's not a man in the Army, remember that not means I can do 1 minus the probability of everything after that not. So man in the Army. So I'll have 1 minus. If I look at the men in the Army, that's this tallest purple bar, which is 490,000. Put that over the total number of people that we looked at, which was the 1,420,000. So I'll do 1 minus 490 divided by 1420. I'm going to hit the fraction button, and it gives me 93 over 142.